Okay, so let me share. So what we're gonna do today, we're gonna kind of cover the section 4.2 today. Okay, so we're gonna start with section 4.2. Okay, because this was something that we left in our last class from chapter 4, and rest of the things we have already covered. Okay, and then we will move to the chapter number 5. Section number 4, why I left it in our last discussion, it was one of the reason was that it contains introduction to a notation actually. Okay, and this notation is very important. So in that sense, I said that, okay, let's do it separately. Okay, and with a fresh mind actually. All right, so how many of you people know this notation or heard of this notation actually? Have you heard of this notation? What does this symbol is called?
Yes, sir. Summation, sir. Yes, sir, we heard about this.
So you have heard about it. Okay, if you haven't heard about it, so that means that it's just 1 or 2 people who have heard about it. So let's start with, with a very basic introduction. So it's a very clever way to say, to summarize some of the very complicated expression. Imagine you have a sum. Okay, so imagine I have this 1 plus 2 plus 3 plus so on and so forth, and plus, okay, say not so on and so forth, but let's write with all details actually. Okay, let's write it with all details and say you have the 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and eventually you will start getting bored actually.
Sir, excuse me.
जी
Sir, screen नहीं ज़ाहिर हो रही आपकी.
स्क्रीन शेयर नहीं हो रही है?
Sir, हमारे पास तो नहीं आ रही.
नहीं बेटा, स्क्रीन तो शेयर हो रही है. So, is everyone can see screen of mine?
Yes, sir.
Yes.
Yes, sir.
So
Yes, sir. Yes, sir.
So everyone can see the screen actually. So there must be some trouble. So you can have a look. Okay. And this lecture is also been recorded actually. So you can, I mean, if there is some issue, you can, see it later as well. Okay. Anyway, so in other words, I can write this 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 9 plus 10, and you will start getting bored actually. So I can bore you with another series, for example. Okay, say 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 and so on and so forth. So I can bore you with the with the different series actually. Okay, with the different series. Now what we're going to learn now is how to write this sum, which is say starting from 1 to 10, and or maybe you have to write this sum from 1 to 1000, and you have to write this say sum from 1 to 1 million. Okay, so in other words, like you have to write this big sum. Okay, you have to write this big sum. Please mute yourself, beta. Okay, then how to write all such sums very compactly. Okay, so the strategy of doing it, that first you need to figure out what is the pattern that is going on here actually. Okay, so if you want to, so in other words, there is a sequence 1, 2, 3, 4, 5, 6, so on and so forth. So if I want to generalize this sequence, okay, so let's talk about this sequence. What would be the general form of this sequence actually? What are you gonna say? So the general form of this sequence is, beta ye aap, please ye अपनी आवाज जो है ये बंद कर दें, ठीक है? ठीक है जी. So the general form of this sequence is going to be what? So it's going to be, I know that it is going to be what? So you can figure it out that this is going to be n actually. ठीक है? Is going to be, यार एक ही बार आ जाओ यार सारे लोग. But the class is starting at 9 a.m. actually. So try to come on to the time actually. Okay, so I mean, if everyone is coming at it at his or her own convenience, then is all the time just goes on to the admitting on the people actually. So try to stay on the time, try to come on the time. Anyway, so you have this series, and I want to write it compactly, and the one of the way is to do what that first figure out that what is the pattern that is working behind this sum actually. So the pattern is that okay. So 1, 2, 3. What would be the general term of this sequence 1, 2, 3, so on and so forth, if for such sequence actually? So who can tell me the general term? What would be the general term? Anyone?
N,
L.
sir.
N. So it's gonna be N actually. So what we're gonna write says okay, the general term is N. So what we are doing, we are summing N. From where? From 1 to 10 actually. So I'm gonna write a notation. I'm gonna say that I'm summing. So this sigma, this symbol is basically, the symbol sigma. This, how to read this, that I am summing what ends, okay? From where to where? Then you have to tell that, okay, if you are summing it from where to where. So I'm summing it from 1 to, what do you say, 10 actually, okay? So now this guy is same as this entire expression actually. And you can have, for example, a sum from 1 to so on and so forth, and up to say 3,535. Okay. So what would be the compact way to write it? Rather than writing all these numbers, you're going to say that I am summing what? N, which is the general term of this sequence, from where to where? From n equal to 1 to n equal to 3,535. Okay, that's what it is. Now, what would be the way to write this? So first we're going to figure out what is the nth term of this sequence actually. Okay, what is the nth term of this sequence and how do you usually find it? I hope that you have learned this actually in your previous classes, that if so this is kind of what kind of sequence is it? What is the name of this sequence that is working behind this sum?
N square.
नहीं n square तो नहीं है.
So 2n
2n
minus
minus 1.
Exactly. So even it's arithmetic series actually. So the first thing that we should say that even the both of these series is like this series and this series, they both are arithmetic series. So do you know arithmetic series? Arithmetic, say sequences and series. So what's an arithmetic sequence? Imagine you have some first term and then you add a fixed term to the previous term actually. So I have A and then I'm adding A to D and I am adding D to the previous term. So it's going to be A to D and so on and so forth. Okay. And so what would be the nth term in this, what do you call sequence? So what we can say, see actually that the second term is A plus 1D and the third term is A plus 2D. So the nth term must be A plus n minus 1D actually, okay? So this is really the recipe to find the general term of an arithmetic, what do you call, sequence actually, okay? Arithmetic sequence. So, so, so what we can do, we can start for example from here. Okay, so what is the A here in this term? In other words, in this sum, what is this? The first term. The first term is 1. Okay, and what is the difference between the terms actually? So 3 minus 1 is 2, and 5 minus 3 is 2, and so on and so forth. So the difference is also 2 actually. So then you can also compute the nth term of the sequence using these two numbers. So it's going to be A, in other words, 1 plus n minus 1 times what do you call difference actually. And if you simplify this, the nth term is going to be 2n minus 2 and plus 1. So it's going to be 2n minus 1 actually. Okay, so the 2n minus 1 is also fine. 2n plus 1 is also what you call fine actually. So I did what? I really generalized, I tried to find the sequence that is working behind this series. So if I have to write this in my sigma notation, then how I'm gonna write that? Okay, I'm summing what the 2n minus 1s, which are odd numbers, okay, and that these numbers starts from n equal to 1 and goes up to what? So what term is going to be the 13th term? How can I know it? I'm not gonna say that the sum is going from n equal to 1 to what do you call 13 actually. This would be wrong. Why it would be wrong? Can you see it? Because
There are
13 13 number है sir, term नहीं
exactly,
है.
exactly. So if you substitute 13 here, so it's gonna be 13 times 2 26 and 26 minus 1 25 actually. While this is not ending at 25. So where should we end this sum actually? कहाँ end करना चाहिए? So
7.
so you have to kind of figure it out. I mean, if like, okay, some people can directly guess actually that, okay, what is this term? But you can also find this term through this formula actually, the formula that we have developed actually, that you have learned previously. How to say it? How you're gonna say that? Okay, I don't know that what term is 30. Okay, now just substitute. I want to find the n for which the nth term is 13. So just substitute the value a plus n minus 1 into d equal to 13. And then I know that a is 1 plus n minus 1, n is unknown to me, and this is 2 actually. Okay. So if you simplify this expression, what value you're gonna get actually? So you're gonna get 2n minus 1 equal to 13. So therefore n must be equal to 7 actually. Okay, n must be equal to 7. So the sum is going from n equal to 1 to n equal to what do you call 7. Okay, so that's how you have to write these sums in kind of the new notation actually. Let me give you some more examples. How about if the sum is not starting from 1, but say sum is starting from 15 actually. The same sum, 15 plus 17 plus 19 plus 21 plus say 20, I don't know, 3 and so on and so forth. So I want to write this as a compact notation. So what should I do? What would be the sum notation? So obviously these are the numbers, that are odd numbers. So the sum is going to be 2n minus 1. Okay. But now you have to think carefully about the limits actually. That is, it starts from where to where actually. So it starts from where to where? Who is going to tell me?
15 to 23.
No, not 15 to 23. No.
Sir, start from first term, n बराबर 1.
So what you have to do, okay, so here is the thing. What you have to do that, okay, you have to figure out that what term is the 15 and what term is in the sequence is, I don't know, 13 actually. No, 23. Okay, there can be several ways actually. So 2n minus 1 equal to 15. 15. So what would be n in this way actually? So n is going to be, I don't know, 1. So if you send the 1 on other side, so you're going to have 16 divided by 2. So this is 8 actually. And what is the 23rd term actually? So again, you're going to compute it 2n minus 1 equal to what? 23. Okay, 23. So therefore the n must be what? So send 1 on the other side. So you're going to have 24 divided by 2. So you're going to get what? 12 actually. Okay, so the sum goes from 8 to 12. So that's how you have to kind of carefully see that, and you can see actually that all of this sum, all from this expression you can recover this. So for example, if you substitute 8 into this expression, what you're going to get? You're going to get 15. If you substitute 9 into this term, so 2 times 9 is 18 minus 1, so you're going to get 17, and so on and so forth. If you substitute 12 into this expression, so 2 times 12 is 24, minus 1 is really the 23 actually. Okay, so that all terms can be recovered from this sum actually. Okay, what if I want to start this sum from 1? Can I start this sum from 1? Can someone tell me some strategy, some way so that I can start this sum from n equal to 1? Another way could be that, okay, you see that in order to write this thing in the form of a sum, I have used the expression, okay, that we developed previously. In other words, expression for this 2n minus 1. By the way, this is not wrong. This is correct actually. But you can rewrite a sum in multiple ways. So for example, if I want to start this sum from n equal to 1, then try to figure out what do you call is the general term for this sequence. And in order to figure out the general term for this sequence, what you have to do, you have to say that, okay, the nth term is going to be a plus n minus 1 times d, but a is what your term, the first term, in other words, it's 15, plus n minus 1 times, what is the common difference? It's 2 actually. So if you simplify this, so the term n is going to be 2n plus 2n plus 13 actually. So this is going to be n. Okay, so if you use this as the representation of the sequence that is corresponding to this series, then yes, you can do it. So that, okay, write 2n plus 3 and then start the sum from n equal to 1. Because if you're going to substitute n equal to 1, what are you going to get? You're going to get 2 plus 13, which is 15 actually. And then the sum should end where? So it should end at n equal to something. But how to find that something? Okay, the way to find that something is that, okay, equate your general term with the last term actually. So you have this 2n plus 113 equal to what? 23. Okay, and then try to find the n. So the n is going to be 23 minus 13 divided by 2, so it's going to be 5 actually. So this sum starts from 1 and goes up to 5 actually. So if you substitute say n equal to 1, so you're going to get 2 plus 13, which is 15. And if you substitute say n equal to 5, so you're going to get 15 times 5 times 2, 10 plus 13 is going to be 23 actually. So you see that all of these terms can be recovered through this sum and also this sum actually. In fact, you start this sum from anywhere you like it. So someone has Someone has commented something. Is it making sense? Ko samajh aa rahi hai baat?
Yes, sir.
Yes, sir.
And I can give you a kind of a say if I give you, okay, how about going other way around? For example, if I say that, okay, I have a sum that starts from say n equal to 1 and goes up to 13, and the sum goes like this actually. Okay, so 4n plus 3. Okay, this is my sum. The question is, what would be the expanded form of this sum actually? So what does this sum is saying explicitly? So previously we went from sum to this notation, and now I want to go from this notation to the sum. And the way to do it is going to be what? That, okay, you take your first term and substitute it here. So when you're going to substitute it, what are you going to get? 4 plus 3, yani 7. And then substitute n equal to 2. So it's going to be 4 times 2, 8 plus 3, yani 11. Okay. Plus so on and so forth. And the last term is going to be that if you substitute 13 into it, so it's going to be 12. कितने हो जाएंगे? I don't know,
55.
13 times 4, okay?
55.
55.
55 किधर से होंगे? 52 होंगे ना? ठीक है? So
3.
it goes up to, अच्छा plus 3 भी है, ठीक है? So it's gonna be 55 actually. ठीक है?
55.
So this sum goes from 7 to what do you call, you know, up to 55 actually. ठीक है? So in fact, you can write any sum, okay, in this manner, in this sum actually, okay? By the way, can some, how about if I have this kind of a sum, okay, so 2 and 4 and 8, no, but 2 plus 4 plus 4 plus 8 plus 16 plus 32 plus so on and so forth. And say it goes up to, I don't know. Okay, so let's just write these, say plus last time 64 actually. So how are you gonna write this? What kind of series is this actually?
N square.
N square.
2n.
So it's a, okay, so here's the thing. So what is the nature of this series? Can someone tell me? So it's a geometric series actually. And how does the geometric series goes like? That, okay, you have a first term, okay?
Find ratio.
You have a first term, okay? You have a first term, say A, and then a fixed number is multiplied with the previous term. So say for example, R is multiplied, then R is multiplied with the previous term, AR square, and R is multiplied with the previous term, AR cube. So on and so forth. So this sequence is called the geometric sequence. Okay. This sequence is really called the geometric sequence. And this is really the sequence like this actually. So you have a 2 and the 2 is multiplied with 4. So what you're gonna get? So 2 is multiplied with a 2, so you get 4, and then a 4 multiplied with 2 is you get 8, and 8 multiplied with 2 you get 16, and so on and so forth. So what would be the nth term of this sequence? Can you guess actually? So the first term is A, second term is AR, and the third term is AR square, and the fourth term is AR cube. So the nth term should be AR, and what power? N minus 1, one less actually than this actually. Now using this formula, can you find the general term of this sequence? The answer is yes actually. So take A to be what? 2. And R is what? R is the ratio actually. I mean, it was a common difference, but now you have a ratio. So if you divide AR by A, you get R. If you divide AR squared by AR, you get R. Okay. So the R must be what? In other words, what is the number that is being multiplied with the previous term? So the number is 2 actually. So if you substitute this, so you're going to say that the Tn is A, which is 2, and R power n minus 1, which is 2 power n minus 1. Okay. So in general, this is going to be 2 power n. So if you want to write, and now you can see actually that someone was saying 2n and someone was saying something else actually, but it turns out that the general term of this sequence is 2 power n. So if you have to write this in the form of a sum, so you're going to say that, okay, you have this 2 power n, and the sum starts from what? So what value of n should I put here so that I get, what do you say, 2 actually? So the first term. So I'm going to say that, okay, it starts from n equal to 1. And then end up to which term? Like this term. So in other words, what power of 2 will give you 64? In other words, if you have 2 power n equal to 64, then what is going to be n? So the 2 is going to be, I think, what power? Okay, so 2 square, cube, 4, 5, and 6 actually. Huh? So n must be 6. So this implies that n must be 6 actually. So the sum should start from 1 and it goes up to what you call 6 actually. And that's a compact way of writing it. Is it making sense?
Yes, sir.
What if this series would have started from 8 and 16 plus 32 plus 64? What if the series with sum would be this actually? How are you going to write this in compact notation? Then you're going to say that, okay, this is going to be a sum that starts from 2 power n, where n starts from where? 3, because 2 power 3 gives you 8, and it goes up to 64 actually. And what power of 2 is going to give me 64? So I know that n equal to 6 is going to give me the 64. So that's really is the way to do it. Okay, are you getting the point? All right. So if we are happy with this, then let me make, let me go from, let me go to some of the very interesting kind of series actually. By the way, let me say one thing explicitly, that that what? Okay, so someone has sent a message. So what is that message? All right. All right. So you have to keep this thing in head that, okay, so if I'm using say n for in the sigma notation, say n equal to 1 to n equal to 6, 2 power n. So this is going to give me, what do you call, a sum that starts from 2 and goes up to 64. But I can represent this sum by any symbol I like. So it's the n is not the only symbol that is going to use. Sometimes I'm going to write k equal to 1 to k equal to 6 and 2 power k. This is also going to give me the same number, because if you substitute k equal to 1, you're going to get 2. And if you substitute say k equal to 6, you're going to get 64. Okay. So the symbol doesn't matter. I can write anything. So I can write I equal to 1 to, what do you say? I equal to 6 and 2 power I. They all are the same thing. Okay. So if the expression would not change its value if you change the symbol. If you are changing something, in other words, that, okay, you have this sum and on the other side you have this, okay, j equal to 2 up to j equal to 5 and 2 power j, then you are talking about two different sums. They are not equal actually. Because this sum starts from 2 and goes up to 5, and this starts from 1 and goes up to 6. Okay, maybe the representative is same, 2 power n is same as 2 power j, it doesn't matter, but these are two different sums actually. So like this starts from 4 and goes up to 2 power 5, in other words 32 actually. Okay, so they are two different sums. So the key point is that by changing the symbol, the sum would not change actually. Okay, the sum would change if you change the either indices here, okay, or you change the what do you call symbols here actually. Okay, if you want to change the symbol, for example, so let me mention another important thing actually, which is important. Say for example, you have this sum that goes from n equal to 1 to n equal to say 6 2 power n. All right, but I want to replace n with say, I don't know, something like I want the power not n, but I want say power k plus 1 here. In other words, I'm replacing n by k plus 1. Okay, let's replace n by k plus 1. Then you have to do what? You have to replace n by k plus 1 everywhere. In other words, here, here, and here actually. All right. So this 2 power n will become what? 2 power k plus 1 and sum. And if you have n equal to 1 and you are replacing n by k plus 1, so that is going to be the k plus 1 equal to 1. So the k must be what? 0. So this n equal to 1 will become k equal to 0. And n equal to 6 means k plus 1. All right. And what? K plus 1 equal to what? 6, because n is 6. So therefore the k must be 5 actually. So k must be, what do you call, 5. Now these are the two sums which are really equal to each other, and apparently they have different indices as well. Okay, they have different indices as well. So you have to be very careful in saying that the two sums are equivalent or not. So what you have to do, you have to start substituting the first value and try to substitute the second value and then substitute the last value and see you get the same sum as the sum that you have above actually. Okay, the same sum as the sum that you have above. So there are plenty of exercises for, you know, for change in indices actually. So you can always change the index as well, you know, as per your convenience and requirement actually. If there is a question, you may ask the question here, then otherwise I'm going to remove this basically. इसमें कोई सवाल है तो जरूर पूछे बेटा. And you can replace this n with k plus 1 or anything you like. For example, I want to replace n by 2k plus 1. ठीक है, तो पावर क्या हो जाएगी? It's gonna be 2 power 2k plus 1. और फिर you also have to change the sum actually. So सबसे पहले 2k plus 1, you're gonna equate it to 0, so you're gonna get k equal to 0. And if you say replace 2k plus 1 equal to 6, and then the k is going to be something actually. Anyway, so these are the little things that we gradually gonna learn. And you have to make yourself comfortable with this summation notation actually. So I want to now have fun with this summation notation. Can someone tell me what would be this sum? K equal to 1 up to k equal to n and just k. What will be this sum? क्या होगा ये sum? Anyone?
N time n plus 1 over 2.
So you're gonna say that, okay, substitute k equal to 1, so you get 1 plus, then substitute k equal to 2, so you're gonna get 2 plus, so on and so forth, plus
Up to n terms.
up to n terms.
Sir.
N terms actually. ठीक है? And do I know anything about this sum? That what does this sum is?
Yes, sir.
we have seen previously that this is equal to n times n plus 1
into
over
n plus 1 divided by 2.
exactly. So in other words, and how about so in other words, summary is just that if you have a sum that starts from k equal to 1 to k equal to n, okay, and the object is k, then you're gonna have what? You're gonna have this is going to be equal to n times n plus 1 over 2. Okay. How about if you have k equal to 1 to k equal to say n, okay, and 2k minus 1 actually. What would
Odd
be this
numbers.
one? So this is
Odd
going to be the
numbers.
sum of the odd numbers, 1 plus 3 plus so on and so forth plus 2n minus 1. And this sum is going to be equal to
सर odd number के लिए plus 1 होता था ना,
n
minus 1 तो
square.
फिर minus this 1 लिया है.
And you have to see this कि अगर आप k equal to 1 substitute कर दें, so what are you going to get? 1. ठीक है, और k equal to
Yes
n
sir, सही
substitute
है
कर
सर,
दें तो
वही है.
2n minus 1, so it should be okay. अगर आप if you want to so that's a good point actually, that if you want to start from k to k plus 1, then you have to start the k from where, so that you can get a 1.
0 sir.
So you have to start from 0 and you have to end somewhere. सम को कहाँ एंड करना पड़ेगा ताकि आखिरी टर्म जो है 2n minus 1 हो, so that the last term become 2n minus 1. So this should be, you can, I mean, if you can't see it directly, just equate your general term, okay, with the term that you want actually. In other words, 2n minus 1. So what would be the value of k here? So it's going to be the k is going to be if you substitute, simplify, it's going to be n minus 1. So you're going to have n minus 1. Okay. So these two terms apparently look different, but they are representing the same sum actually. Okay. So if you have a 2k minus 1, then it starts from k equal to 1 to n. If you have k equal to 0 to n minus, if you have 2k plus 1, then it starts from k equal to 0 to n actually. Okay. So I know that that what? So the next is really this, that okay, if you start from say k equal to 1 to k equal to n, and you have this sum 2k minus 1, then this is going to be what? N times n minus 1 upon 2. Okay? No, not n times, n square, sorry.
नहीं.
My mistake. Sorry. Take care of yourself, the crazy days are going on. Okay. So what would be k equal to 1 to k equal to say n and k square? What does this sum is going to represent? So this is going to
ये
be
दोबारा
1 square,
yes sir.
not 4, but plus n square actually. 1 square plus 2 square up to n square. And what is this sum? Does anyone remember the identity?
Sir, n into
N
Perfect
into
case है ना.
j.
n minus
Sir,
1.
n into n plus 1, 2n plus 1 divided by 6.
Exactly. N into n plus 1,
Yes,
2n
sir.
plus 1 divided by 6. These are the
Divided by
basic
6.
identities that you should always remember actually. So in other words, if I have a sum that starts from k equal to 1 to n, and I have a k square, this is same as n times n plus 1, okay, times 2n plus 1 and everything divided by 6. And how about if I have a sum that goes from k equal to 1 to k equal to n, okay, and I have say k cube actually. Well, this is going to be 1 cube plus 2 cube plus so on and so forth and n cube. So what is the formula for cubes? it's same as this, but a square actually. So in other words, n times n plus 1 over 2
1
and it
divided by 2 whole square.
is square actually. Take the sum that goes from k equal to 1 to n. Okay, so it's gonna be k cube is gonna be uh, k times what? Not k times. So it's gonna be n times n plus 1 upon 2. Okay, so you have this n times n plus 1 upon 2 and it's a square actually. Okay, so that's what is really. So these are the some of the identities that you always should remember, okay, because these are going to be used always, like these ones. And we're gonna
सर
see J.
सर अगर हम सर के से 0 से स्टार्ट करें सर
So if you want to start
तो
k
फिर
from
तो सर
0, if you want to start k from 0, ठीक है, आप करना चाहते हैं तो कर सकते हैं. For example, if I want to start k from 0, देखिए इस so like this thing would not change actually. The sum is going to stay same. ठीक है? The only thing is that you know the physics of this is going to be a little bit changed. In other words, that you know the subscripts will change. Nothing else will change actually. So for example, you want to start this sum from k equal to say 0 actually. So you want to start from k equal to 0. Say so replace. So what should I put here so that I can get a 0 here? So I have k equal to 1. So what should I do so that this becomes k equal to 0? So
-1 सर
so the
-1.
best would be that replace k by k plus 1. Or replace k by some other thing actually, say I plus 1 or j plus 1, doesn't matter. Okay. Replace k by something else, say I plus 1 equal to 1. So the I would be what, 0. And so if k is I plus 1, okay, then k equal to n will become what? I plus 1 equal to n. So the I would n minus 1. So now you can rewrite this entire expression that, okay, the I starts from 0 and goes up to n minus 1. And you have to also replace your k here. So you're going to have I plus 1 and its cube. So it's really the same sum actually. Okay, the sum is not changing. So you substitute I equal to 0, you get 1 cube. You substitute I equal to 1, you get 2 cube. You substitute I equal to n minus 1, you're gonna get a cube, n cube actually. The sum is same, but their representations are different actually. And this is useful sometimes actually. You're gonna see several instances where you have to change these indices actually. ठीक है जी? So are we happy? Are we all happy with this? अच्छा, अब फर्ज
Yes, sir.
करें, I give you that, okay, try to find this sum for me for the k equal to 5 to k equal to say 15. But before that, I must tell you some properties more of the sums actually. Okay. Okay. So let me go to the sum of the properties of the sum. Okay. If I have a sum like this, okay, instead of having 1, 2, 3, I have this say a1 plus a2. I have a sequence, general sequence, a1 plus a2 plus a3, so on and so forth, and an actually. Then how to generalize it? बेटा ये अपने आप को म्यूट कर दे भाई. ठीक है? So what would be the general way to write it? Okay.
A1 plus n minus 1 into D.
Okay, so here's the thing actually that you have to do. Okay. So you're gonna have a sum So see, A is not changing, it's the indices that are changing actually. So you're going to have a sum in which you have A and an index K actually. So you're going to write AK, okay? And then you're going to say that the K starts from where and goes up to where. So the K, the indices, it starts from 1 and goes up to n. So I'm going to say that, okay, the K starts from 1 and goes up to n actually. Okay, so that's really is the sum that is, you know, represented by this actually. So AK means what? I don't know what these numbers are. So like this could be a general sum. I don't know, even numbers, odd number, whatever, it doesn't matter. Okay, but the general way to write it as that you have this K equal to 1, AK, and you go up to n actually. ठीक है, समझ आ रही है बात? अच्छा, if you have now say A1 plus A4 plus say A9 plus I don't know, A16 plus A25 and so on and so forth. So you want to write this as a sum notation. So what you should write? What you should write actually, bhai? ठीक है भाई, इसको जरा
Sir, K is equal to 1, sir.
ठीक है. So you're gonna say that, okay, let's just start. So first of all, you have to generalize the sequence that you have in the indices. So 1, 4, 9, 16. So what would be the general sequence? So it's K square, right? It's K square, AK square. And the K goes from 1 and up to K equal to n. So if you substitute say K equal to 1, you're going to get A1 square, which is A1. If you substitute K equal to 2, you're going to get A2 square, which is A4. Not n, but so you're gonna, this is going to be 5 actually. Okay, it starts going to start from K equal to 1 and goes up to K equal to, what do you call, 5. Okay, so so you have to see that in expression what things are changing. Okay, what are the things that are changing actually? Is it making sense? All right. Now I would like to come to the some properties of the sum notation actually. Okay, some properties of the summation notation. First, I have a sum that starts from say K equal to 1 and goes up to K equal to n, and I have a constant C multiplied with say AK. So when you're gonna expand this, what you're gonna get? क्या मिलेगा आपको? What would be the explicit expression that I must write on the other side? So the first term, so if the first term is going to be that in your given expression, substitute K equal to 1. So you're going to get CA1 plus then substitute K equal to 2. Yani CA2 plus so on and so forth. And the last term is going to be CAN, right?
Yes, sir.
Okay. So what is the interesting thing in this sum? Can I rewrite this sum in some shape actually?
Yes, sir. C common,
Yes,
sir. C ko.
So pull out the distributive law, C outside of the expression, you're going to get A1 plus A2 plus so on and so forth, AN. Okay? So on and so forth, AN. And if I write this sum again in summation notation, so you're going to get C times of the sum that goes from K equal to 1 up to K equal to N and AK. So the summary is what? The summary is this, that if you have a sum that K equal to 1 to K equal to N, and some constant is multiplied with the term that is changing actually. So what you can do by distributive law, you can pull out this C outside of the sum actually. In other words, I equal to 1, so k equal to 1 to k equal to n and ak. Okay, so in a sum, if you have what do you call a constant multiplied with each term, then you can pull out this constant out of the entire sum. Now, what would be the benefits out of it? No, there are going to be plenty of very interesting kind of benefits out of it. For example, if I ask from you, what would be the sum of, say, maybe k equal to 1 to k equal to, I don't know, 100 of 3k square? Okay, so what would be this sum? So you're gonna say that, okay, so 3 is a constant, it's like C. So what you can do, you can pull this, C out of the constant actually. So if you pull this C out of the constant, so you're gonna get C. And you have K equal to 1, not C, but 3 actually. Okay, K equal to 100, and you're gonna get what? K square. So do I know this sum? The answer is yes actually. Okay, because I know that if I have k that starts from 1 and goes up to n, and if it is k square, then this sum is equal to n, the last term, times n plus 1 times 2n plus 1 over 6. So in this manner, what would be this sum? So it's going to be 3 times of n, which is the last term in 100, okay, times n plus 1 yani 101, times 2n plus 1 yani 201, okay, and everything divided by 6 actually. Okay, and you simplify this number, so this number is going to be the sum that you want. The sum that you want. And in fact, you can really generalize this sum. So for example, if I give you, okay, what is the sum k equal to 1 to k equal to, say, n of, say, under root 2k square, under root 2k square. So what would be the formula for this sum? So I'm going to say, okay, pull out the under root 2 outside of the sum because this is like a constant, and then sum k equal to 1 to k equal to what? N, k square. Now what is this sum? For this sum, I know that this is equal to square root of 2 times n, which is the last term, n plus 1 times 2n plus 1 divided by, what do you call, 6. So hence, from this formula, which was already known to me, I derived a formula for this actually. So what would be this sum? Are you getting the point? So in a given sum, if you have, if you have a constant is multiplied with each term, then you can pull out this constant. Okay, so can someone tell me what would be, say, k equal to 1 to k equal to n, 3k, what would be this sum? Do your direct calculations and क्या होगा ये sum? What would be this sum?
Sir,
Sir,
3
Sir, 3 sum
3
summation से बाहर
multiply
चला जाएगा
n.
So pull
into
out
n plus 1
3,
divided.
k equal to 1 to n, and then 3 times and then k. So do I know anything about this sum?
Sir, n multiply n plus 1 upon 2.
Exactly. So n times n plus 1 over 2 actually. So that's, so if you know the formula for k, so you know the formula for 3k as well actually. Okay. So we saw that this property is really useful actually. It's a very useful property. Okay. Now let me move to the another property. Another property. Property number 2 for the sums. So for example, if I have a sum that goes from say k equal to 1 to k equal to n, but in sum I don't have one sequence, but I have two sequences, say ak plus bk. Okay, ak plus bk. Then what we're gonna do? What would be the explicit form of this expression? So how can I compute it? So I can say that, okay, in the given bracket, general term, first substitute k equal to 1, then substitute k equal to 2, and then, so on and so forth, substitute k equal to 1. So if I'm going to substitute k equal to 1 here, so what are you going to get? I'm going to get a1 plus b1 plus, and then if I'm going to substitute 2, so I'm going to get a2 plus b2, so on and so forth, plus, what would be the last term? An plus bn. So you agree with me? This is what the sum is going to be.
Yes, sir.
Okay. Now on this entire sum, if I apply commutative law and I rewrite this expression as this, so a1 plus a2 plus so on and so forth, an plus b1 plus b2 and so on and so forth, bn. Okay. Then what does this sum is going to be? This is going to be, the first is going to be the sum that goes from I equal to, or maybe k equal to 1 to k equal to n ak, plus the second term is going to be sum that goes from k equal to 1 to k equal to n and bk actually. Are you getting the point? So if I summarize this, that if you have to sum, so k equal to 1 to k equal to n of say the sum of two sequences actually, so ak plus bk. So if you have to sum the sum of two terms, then what you can do is that, okay, this is same as that you first sum them and then add k equal to n ak plus k equal to 1 to k equal to n and bk. In other words, individually apply the sum onto the each term. Okay, so if you have a sum and two terms, then you do what? Apply the first sum onto the first term. In other words, we get this, and then apply the sum onto the second term. Actually, you're gonna get this. So the both are really the same thing. Actually, okay, they are not two the different thing. So the first property that you have to keep in view, that if a constant is multiplied in a sum, so you can pull it out of the constant, out of the sum. And the second important property is that if you have a general sum of the sum of two terms, then this is same as that you apply the sigma notation or the sum to the both terms separately. Okay? To the both terms separately. And once you keep these two properties in head, ये दूसरी property समझ आई है? So have you got this second property? That what does this second
Yes, sir.
property is telling you?
Yes, sir.
Yes. I mean, if you have understood it, now you can see really the miracles of these two properties. For example, now I tell you, what is the sum of say k equal to 1 to k equal to say 100 of say two, someone has messaged in chat. Okay, so it's just yes, sir. So you have 2 plus say 3k and its cube. So this is what the sum that you have to find. And I don't want to substitute, say, k equal to 1 and then k equal to 2 and then k equal to 100 and do the long calculation to find this sum. So what you're going to do, the best way is to use the properties of the sigma notation and the properties that I mentioned previously. So k equal to 1 to k equal to 100 and expand this actually. So when you're going to expand this, what you're going to get? You're going to get 27k cubed, right? Plus 8 plus what would be this? So 3 times 4 times 3k, okay, plus 3 times 2 times 9k square, right? Agree with me? Everyone is happy with this expansion?
No, sir.
सर साइड में लेके क्या कौन सा एक्सपेंशन किया
अब ये a plus b whole cube का formula इस्तेमाल किया ना. So what's the formula for a plus b whole cube? So a cube plus b cube plus 3a square b plus 3ab square. Okay. And I'm now
Okay.
saying that, okay, substitute a equal to 3k, say, and b equal to 2. So what you're gonna get? You're gonna get 27 cube, 8 and 3 times 4, yani 2 square, 3k plus 3 times of 2 times of 9k. I just applied this formula. So I assumed that maybe, everyone knows it. जी मोहम्मद अली, कुछ पूछना चाहते हैं आप? मोहम्मद अली want to ask?
No, sir, no, sir.
चलिए ठीक. So let's simplify this expression. So 27.
सर
जी जी.
सर ये जो अभी हमने सर प्रॉपर्टी की है ना सर पहले वाली सर
जी.
अब उसमें हम करते हैं सर ए के प्लस बी के ये दो टर्म के लिए है ना सर अगर दो सीक्वेंस या सीरीज वाली मिली हो तो अगर n सीरीज हो जिस तरह हमने पहले मैथमेटिकल इंडेक्शन यूज करके फाइंड किया था ना nth टर्म का जो सर जनरल
अगर हो तो आप अलग अलग अप्लाई कर दें. Doesn't matter. 2 हो, 3 हो, 4 हो, 5 हो. Doesn't matter. I mean, you can have a sum, for example, k equal to 1 to n, and you have ak plus bk plus ck plus dk. Doesn't matter. Just apply the sum on each term. Sum ak plus sum bk plus, sum ck plus sum dk. So it doesn't matter how many terms do you have.
तो n तो भी कर सकते हैं
Huh? In good?
सर ये जो हम a के b के c के
Uh-huh.
अल्फाबेटिकल लेटर है तो z तक आएगा अगर यहाँ आप कोई सा नंबर उठाते हैं
But कुछ भी रख ले, doesn't matter. You can individually apply the sum. It's not just limited to the twos. That's it. Okay? So it can have as many as terms you can like actually. Yeah, simple rule. No need to worry. So just apply the sum onto the each. For example, there are going to be 4 terms here in this sum. So 3 times 4 times 3 times 4 12, and this is going to be 36k. Right, 36k plus this is going to be what? 3 times 2 6 and 9 times कितने हो जाएंगे? 6 and no कितने हो जाएंगे? 9 times 6 है?
50,
50.
56.
54
Oh,
54, sir.
54k square. ठीक है, so you have it. ठीक है, and now you can do what? By the previous property, I can apply this sum individually on each term. So I can do k equal to 1 to 100, ठीक है, and 27k cube plus k equal to 1 to 100, 8 plus k equal to 1 to 100, 36k plus k equal to 1 to 100 and 54k squared. Okay. And now if I go one step ahead, now this 27 is like a constant, so I can pull it out of the sum. So I have 27 times what k equal to, okay, k equal to 1 to k equal to what, 100 k cube. Okay, keep the second term as it is because there is no k in this sum. So I will explain this separately, that how to deal with such terms. K equal to 1 to k equal to 100 plus in this sum 36 is constant, so you can pull it out. So 36 times of the k equal to 1 to 100 k, and plus sum that goes from k equal to 1 to 100 and 54. You can pull the 54 outside and you're gonna get, so let me write it in a more kind of neat and clean manner. Okay, plus k equal to what, 1 to 100. So you pull out the 54 outside and you have the k squared inside. Okay. So what would be this sum now? So I have 27 times, what would be k equal to 1 to k equal to 100, k cube. So we know the formula. So we have 100 times 101, in other words, n times n plus 1 divided by 2 and everything is squared. Okay? Plus, I'm gonna in a minute write the second term here. Let me write the third term first. So what is going to be this 36 times, summing, from k equal to 1 to k to 100? क्या हो जाएगा? So this is, so what is the formula for it? N times n plus 1 over 2. N is the last term. So you have the 100 times 101 over 2. All right. Plus 54 times, what would be k squared? Formula for it. So you're going to say you have the 100 times 101 times 2n plus 1. You need 200 plus 1, you need 201. And everything divided by 6 actually. Okay, so you wrote it. And then what would be the summing 8? So this is an important thing that we should, we should learn actually first. So imagine I have only a constant c that I am summing from k equal to 1 to k equal to say n. So what should be this sum? What does this tells you?
तो सम बाहर आएगा और उसके लिए 1 के लिए वो होगा ना.
चलो ये सी बार रख दिया तो फिर भी तो आपको 1 ऐड करना पड़ेगा ना. But what is the meaning?
n के लिए नहीं होता है.
चलो let me tell you a trick actually. Let me tell you a trick. ठीक है? A trick could be that, okay, I don't know, let's put something here actually. So let me put say anything. So just put anything. So for example, I put say so there is no index in this term actually. So what is 2 power 0?
1, sir.
1. So
1, sir.
what if I put 2 power 0 power k?
1, sir.
It's still 1 actually. And now I have, for example, index and then substitute the values into it. So you're going to get what? C times of 2 power 0 power 1 plus C times of say 2 power 0 power 2 plus C times of say 2 power 0 power what? N actually. So what eventually you're going to get? 2 power 0 power 1 is 2 power 0, 2 power 0, 2 power 0. So all these powers are 1. So you have the C plus C plus C and so on and so forth. C.
at C.
n times. ठीक है? So बड़ी सादा सी जुबान में, if you have to sum a constant, say from k equal to 1 to k equal to say n, what actually you are saying is that sum this constant n times. In other words, c plus c, how many times? N times. So if you're going to sum the same number n times, what would be the outcome? So it's going to be n multiplied by c. Simple. Okay, so like, okay, this is just a trick actually. Okay, so there was no index k, but you can get an index a and you can get this actually. So it's just a trick. So don't worry about this. I mean, you know, you can take anything. समझ आ रही है बात? Now, can you tell me that what would be this sum? That I am summing the number 8 from k equal to 1 to 100.
Sir, 800.
Exactly. So this is going to be that the number 8 is being summed at 100 times. So this must be 8 times 100 actually. And now you can, you know, pull out your calculators and calculate this number. There is no need to calculate the number, you know, in this manner actually. Is it making sense? So I can give you any expression and you can try to figure out its sum without really using the calculator actually. Okay? Just by directly using the formulas, by doing the algebraic manipulations actually. Is there a question in this description? I mean, if there is a question, let me know. Otherwise, I'm going to move ahead actually. Okay? I'm going to move ahead. कोई सवाल नहीं है किसी को? अच्छा, let me say do one problem from exercise actually 4.2. Okay, and it's an interesting problem actually. So I have a sum of k plus 28 square, but the sum starts from k equal to negative 29 and goes up to n. So I want to find this sum. So what should I do? The sum starts from negative 29. In other words, negative 29, negative 28, negative 27. In other words, first replace this k by negative 29, then replace it by negative 28, negative 27, so on and so forth, and go up to n and try to find the sum of the formula. So what should I do? If you have a sum that does not starts from say one index, say k equal to 1 or k equal to 0, some of your favorite index, you can always turn into, you know, a sum that starts from k equal to 1, for example, and then apply what do you call the rules. Okay, so what should I do if I have to start this sum from k equal to 1? K equal to, say I have this negative 29 and I want to start this sum from k equal to 1 or, you know, some other index equal to 1. So what should I do? So if I, for example, replace k by, what should I replace k by?
30 plus 1.
30?
Sir, k minus 20, 30, sir.
K minus 30. So you can replace the k by k minus 30, or you can replace k by, for example, I minus 30, doesn't matter. Okay, in other words, take k to be I minus 30. So everywhere in sum, replace, okay, replace k by I minus 30. Okay. So if I replace k by I minus 30, what will this become? K equal to 29. So in other words, you substitute I minus 30 here equal to negative 29. So the I would be 1. How about if I have k equal to n? Okay. So what would be I in this case? So you're going to replace k by I minus 30 equal to n. So the I would be n plus 30, right? Okay. And then see what the sum will become actually. So the sum is going to be with the new notation. Okay. This is going to be I equal to 1 to I equal to n plus 30, right? And what does this interior sum become? So what will become this k plus 28? So the k plus 28 will become I minus 30 plus 28. So it's going to be I minus 2, right? So the sum, this sum will become what? I minus 2 and this square. Okay. Now this sum is precisely same as this sum. So it's like I have changed the sum physically, not chemically. So it's chemically same thing. Okay. So it's physically might look like different, but they are one and the same thing actually, because you have just replaced the indices. Okay. And let's now compute this sum. So how can I compute this sum? In order to compute this sum, I need to expand this. Okay. So if I'm going to expand this, I'm going to get I squared negative 4i plus 4. Okay. And then apply the sum separately. I equal to 1 to n plus 30 and I square minus I equal to 1 to n plus 30 4i plus I equal to 1 to n plus 30 and 4. Okay. Now can someone tell me that what would be this sum? ये sum क्या होगा? So see, this is like, this is same as this actually, that okay, you have this sum that starts from k equal to 1 to n k square. So I know that this is going to be what? This is going to be the last term, in other words, n times n plus 1 times 2n plus 1 and everything divided by 6. So what would be this sum? So you're going to say, what is the last term in this, so it's n plus 30. So you're going to say that this is going to be n plus 30 times n plus 31.
30 plus 1.
Okay. And then you have 2n plus 30 plus 1. Okay. So 2 times of n plus 30 plus 1. So you're going to get 2n plus
So 2n plus
61. 2n plus
1. Yes.
61 and everything divided by 6. So that's what is really the first term. Minus what would be the second term? In the second term, you can pull out 4. And what is going to remain is I equal to 1 to n and I. So what would be this sum?
N plus 30 into n plus 30 plus 1 n plus 31.
So it's going to be n plus 30 times n plus 31 and everything
31.
divided by 2. Okay.
2, yes, sir.
Plus what would be this sum? So it's a constant. So it's like adding the 4 how many times? From 1 to n plus 30. How many times? So n plus 30 times.
4 into n plus 30.
Exactly. So 4 into n plus 30 actually. Okay. And then you have to take LCM and all this and simplify this expression actually, and you get what do you call your sum. So this sum, which looks like a creepy sum, we computed it using the properties of the sum. ठीक है मेरे भाई. So now, if you have understood all this stuff, now you should be able to solve the exercise 4.3, or the most part of the selected parts of the 4.3, especially that involves the uh, the that involves the summation notation actually. Okay, so now you have to solve the exercise 4.2. Exercise based on the section 4.2. Okay, so if you have question, do ask, or you can ask after the break. So let's do a quick 8-minute break actually. So it's 10:22. So let's meet at 10:30 exactly. Okay, and start a new chapter. So get yourself, make yourself fresh, and then let's return to that. ठीक है जी? So let's get back and let me share my screen with you. Okay. And let's move to the next important chapter. So if you have questions or something, if you are having troubles in solving exercises, please do arrange a session actually, okay? And speak with your
Yes,
fellows.
sir,
And
we are willing.
willing है तो भाई
सर
करे ना.
सर चैप्टर 3 के लिए एक्स्ट्रा सेक्शन रख सकते हैं.
रख लें, chapter 3 के लिए रखें. You can put and you can do as many as the sections you like actually. ठीक है. So if you have questions, do arrange the session. Actually, I'm free on Thursday, Friday, Saturday. So these are the 3 days that I'm available actually. So just throw me that when you are
सर चैप्टर
available.
3 में इश्यूज है सर.
So if you have issues, then do discuss with me. Okay, so just set up when you want to have that session.
सर थर्सडे सैटरडे कभी भी हो सकता है.
I mean, okay, set up a timing when all people are available. Okay, and then just email me that this is the time that we would like to have the session. Okay.
सर
ओके सर. ओके
करके बताएंगे सर, डिसाइड कर लेंगे.
Huh? Okay, so now.
सर पूरी क्लास के साथ बात सर.
I mean, it depends on those who have problems, they can attend the session. If those who don't have any problem, they can really leave the session, no problem. Okay.
ओके सर. ओके.
All right.
4.6 and 7 नहीं पढ़ेंगे.
4.6 and 7 in the session. No, we're not going to do that actually. So we're not going to cover everything. Obviously, it's going to take a lot of time. So I just in last discussion, I gave you an introduction to mathematical induction, and now I gave you introduction to the summation notation actually. And this is enough from induction chapter. So now I would like to move to the set theory. All right. About the sets, we have already discussed few things, and I gave you set of exercises as well, okay, which you might have tried. If not, do try them. If not, now you can try, doing exercises from the sets actually. So let's recall some of the stuff that we did in sets. I'm not going to repeat all that. I'm just going to repeat, some important bits of it, and then, do say for example some proofs with you. So I'll hit the more important, what do you call it, stuff actually. Okay, so I have say a statement here, okay, and it's a definition here, and here I'm gonna write its negation. Okay, so that's what I'm gonna do. So I have a statement, its description, and its negation, and this is going to be about the sets. So the first statement is, okay, so what is meaning of say an element being in a set actually? So if you have a set A, okay, then what are the meaning of X being in A? So the definition is what? You can say that it's really the same definition, X belongs to A. What would be the negation of this? X does not belong to A. Okay. Or there is another thing actually. X belongs to A complement. Okay, so the negation of X belongs to A is that X, even the one thing is X does not belongs to A, but if you want to write this thing in a positive form, then X belongs to A complement actually. Okay. And one thing that is important actually that one must note actually that if X belongs to A, X okay, so if X belongs to A, X does not belongs to A complement, and if X belongs to A complement, X does not belongs to A. J. Okay. How about if I say that X belongs to A union B? what is the definition of it? What does it mean? It means that X belongs to A
X
or
belongs to A or
X belongs
X
to
belongs
B.
to B.
Okay. What would be the negation of it? The negation of A
X does
is,
not belongs to A and X does not belongs to B.
okay, so X does not belongs to B. Okay. So that is really the meaning. So this is really the meaning, or this is really the meaning of X does not belongs to A union B. So when I'm saying that X does not belongs to A union B, this means that X is not in A and X is not in B. Okay. And when X belongs to A union B, that means that X is A or X is B. Okay. These are important things that we should recall. We have discussed these previously. How about if I say that X belongs to A intersection B?
X belongs to A.
X belongs to A and X belongs to
Let
B.
me rewrite all these things in another manner actually. Sorry. Okay. So I mean this is fine, but let me rewrite it in another manner. Okay. Let me rewrite this in this manner. One. I'm gonna say that X belongs to A if and only if X does not belongs to a complement, right? So if X is not an A complement, this means X is an A, and if X is an A, it means X is not an complement. And so if this is in a statement, what would be the negation of it? So this is a statement, and what would be the negation of this statement? So negation is going to be X does not belongs to A if and only if X belongs to a complement. So if X is an A complement, X is not an A. And if X is not an A, X is an A complement actually. Okay, these two things are equivalent. What would be the second thing? Say the X, if the X is in A union B, this is going to be true if and only if X is in A or X isn't B. Okay. What would be the negation of this statement? That X does not belongs to A union B. So in other words, negate both. So equivalent statement. So this is important to realize that if two statements are equivalent, then their negations are also equivalent actually. You agree with me? Have you seen such rule? That if two statements are equivalent, then their negations are also equivalent actually. So if X is equivalent to X belongs to A or X belongs to B, then X does not belongs to A union B is equivalent to saying that negate this actually, which is X does not belongs to A and X does not belongs to B. Okay. So we have discussed all this in detail actually. So these are the statements equivalent to each other, and these are the negations that are equivalent to each other. So when I'm saying that X does not belongs to A union B, this means that X is not in A and X is not in B. And if X is not in A and X is not in B, then this means that X does not belongs to A union B. The
So
third,
negation को X belongs to A complement and X belongs to B complement form में
B
लिख
कह
सकते हैं
सकते
ना?
हैं. Yes, this you can also say that this is same as that X belongs to A complement and X belongs to B complement. But you can also say this as X belongs to A complement intersection B
भी हो
complement.
सकता है.
So like these are the things that you can deduce actually from all that. Okay, but the basic description is okay. The basic description is that okay, that if X is in A, it means that X is in A union B, then X is in A or X is in B. Then if X is not in A union B, then this means that X is not in both A and B actually. How about intersection? How about intersection X?
वो end आएगा.
Exactly. So X belongs to A intersection B if and only if X is in A and X is in B. All right. And that's a statement. And the negation of this statement is going to be that X is not in A intersection B. And this is going to happen if and only if negate this. It means that X is not in A or X is not in B. Okay, so this follows from the logic actually. And then, okay, then how about if I say the fourth one, that what is the meaning of X belongs to A minus B? So this is true if and only if X is in A and X in not B. Okay, so X is in A, but X is not in B. What would be the negation of it? What is the meaning of that X not in A and B? This is going to be true if and only if, just negate this. And what would be the negation of this? This is going to be X is not in A or X is in B. So an element is not in A difference B. There can be two reasons for it. Either this element is not in A, so therefore, the element is not in A minus B. Or the second reason could be that X belongs to B actually. So if you have an element that is in B, okay, that element is also going to not come in B actually. Okay. In other words, if you have A as 1, 2, 3, and B as say 3, 4, 5. So in A minus B, 6 would not come. So 6 does not belongs to A minus B. Why? Because you're going to say 6 is not an A. Another thing, that 4 would not belong to A minus B. Why? Because 4 is inside B actually. Okay, so the 4 is inside B. So anything that is inside B is not going to come in the A difference B, which is, so what is the A difference B? A difference B is 1, 2, 3. Okay, 1, 2, 3. Okay. So these are the basic things that we should keep in our head actually always. J. All right, so now the most important property along with all these 5. Okay, and this is what is the meaning of A being subset of B. Okay, so we're going to say that A is subset of B if and only if what happens? For all X, if X is in A, this implies that X is in B. So any X which is in A, it should also be in B. Okay, so that's really the definition of A subset of B actually. In other words, if you want to prove that A is a subset of B, pick an arbitrary element from A and prove it that this element is also present in B actually. Okay, this element also present in B. All right. What would be the meaning of A subset of B? A is not subset of B. So what you need to do, you need to negate this statement. And what would be the negation of it? The negation of it is going to be there is some X which is in A and that X is not in B actually. Okay. So if you have an element which is in A and that is not in B, then you're going to say that A is not subset of B actually. Okay. And the sixth thing is that what is the meaning of equality of two sets? So the equality of two sets means that A is subset of B and B is subset of A. Okay? These are the basic things that we have discussed. What do you call previously? Okay, all of these things we have discussed previously. There is nothing that we have kind of left actually in this. All right. Okay, so you have to do what? Based on these definition, you have to prove some identities. For example, in 5-point exercise, if you take the exercise 5.2, okay, from the book actually, you should be able to do all exercises actually. For example, let me do some problems for you actually. Let me do J 5.1 की तरफ भी आते हैं. So we're going to come to the 5.1 as well, but I would like to just throw the 5.2 to you. Okay? So in book 5.2, so for example, we have to prove this theorem. Okay? So theorem goes like this. So if A is subset of B, then, okay, A is subset of A union B, and A is subset of A intersection B is subset of A. Okay, that's the statement actually. In other words, if you make a picture of it, that okay, that's your B, and this is A inside B. So that's A, and this entire set is B actually. Okay. So what does this result is telling you? This result is telling you, first of all, A, when A is a subset of B, A is also subset of A union B. So what would be the A union B in this picture? So in other words, combine A and B. So that's my A. And you know, and if I substitute say B into it, so the A union B is really B actually. Okay, so the A is subset of B. And if and why A intersection B is a subset of A? So that's my A and that's my B. So the B is this entire set while A is a part of it. How can I compute the intersection of it? So first thing is that you should, so whenever you are writing a set theoretic theorem, you should be able to make its picture actually, because picture is going to reveal everything. So how can I find intersection? We have discussed all these things. So therefore I'm going a bit fast actually. That okay, draw the horizontal lines in say A, okay, and say vertical lines in the entire B, and see where these lines are matching with each other. Okay, so where they are matching. So they are matching in A. So from this you can conclude actually that A intersection B is basically A, and A union B is basically what? B actually. So if A union B is equal to B, then you know A is subset of B, and I know that A is subset of B, then A is subset of A union B for sure, because A union B is B. And if now since A intersection B is A, okay, A intersection B is A, then I can say that A is subset of A. So why A intersection B is subset of A? Because A intersection B is A itself actually. Okay, so you can see it pictorially. But our task here is not to prove this pictorially, but prove it by definition actually. So prove it by definition. So what is given to me? It is given to me that A is subset of B. Okay, this is what is given to me. And let's first prove that A is a subset of A union B. Okay, let's prove this. And how I'm going to prove it? In order to prove that one set is subset of other, you have to show that every element that belongs here is also here actually. So let's pick an element from X is in A. Okay. Now if X is in A, can we say that X belongs to A union B? The answer is yes, actually. Because if X is in A, then I can say that X belongs to A or X belongs to B. And in this R statement, this part is true. Okay? This part is true. And in a given R statement, if one part is true, then the entire statement is true. Okay? The entire statement is true. So I can say that since X belongs to A, then this statement that X belongs to A or X belongs to B is true. Hence, I can say that since X belongs to A or X belongs to B, so X belongs to A union B actually. Is it making sense? So we picked an element from A and proved it that it belongs to A union B. I'm going to say thus, or maybe hence, or maybe therefore, whatever you write it, that A is a subset of A union B. This seems like a very trivial, result, but you have to argue about it. So we are done with the first part. So what is the second part? The second part is to really prove that A intersection B is a subset of A. Okay. So in order to show this, what we need, J.
सर यहाँ पे हमने सिर्फ एक एलिमेंट लिया ना, x बिलोंग्स टू a, कोई एक एलिमेंट है. अगर ऐसा भी तो हो सकता है सर, a में कोई एक एलिमेंट ऐसा हो जो b में ना हो, उसके लिए क्या करोगे?
अगर ऐसा एलिमेंट है, if there is an element which is in A and X does not belongs to B, then this condition, ये जो condition है, this is still true. This is a true statement. Why? Because one part of it is true. देखो ना भाई, आपके पास एक element है. So you have the set 1, 2 and you have set this 3, 4 or maybe 1, 3, 4. Okay. So I'm going to say that, okay, 2 is in A, but 2 is not in B. Will this 2 is going to come in A union B? The answer is yes. Why it is going to come? Because the 2 is in A. Okay? And if you want to say this logically,
अगर हम यहाँ पे सर for all x लगाएं तो सही होगा?
नहीं बेटा, for यहाँ जब आपने arbitrary x ले लिया ना, तो for all x हो गया. So this x is not a one element. This is an arbitrary x actually. Okay? So it could be any element. It could be 1, it could be 2, it could be anything. So he's saying that, okay, let's pick any element from A, and then since x belongs to A or x belongs to B is true, so x must be in A union B. Okay, so this is true. Why true? Because one part of it is true. And you picked an element from A and shown that x is also is in A union B, so the A must be subset of A union B. It's really the वो जो arguments आप पढ़ते हैं, if P R Q is true, okay, and I don't know, if P is true, then P R Q is true. ठीक है? ये पढ़ा था, ये पढ़ा है argumentation वाला rule?
Yes, sir.
Yes, sir.
In an R statement, if one part is true, the entire R statement is true. Okay, that's what is really.
Yes, sir. Yes, sir.
This is what is really happening. And now, so for example, if you have X belongs to A intersection B, then by definition, X belongs to A and X belongs to B. Therefore, I can say that this shows that X belongs to A. So it's like your modus ponens, huh? That if P and not Q is true, so you can conclude that P is true. If an AND statement is true in which the both parts are true, that means that each part is true actually. So if X belongs to A and X belongs to B, therefore X belongs to A. So you picked an element from A intersection B and you proved that that element belongs to A. So this means, so you're gonna say hence A intersection B is a subset of A actually. Okay, so the both parts are true, and this completes the proof. This completes the proof. Okay, so this looks like a trivial result, but you know there are things that you have to carefully think about it actually. Okay, for example, let me give you another example. Okay, as to does anyone have any question here? सवाल है तो पूछें. So see, I'm directly coming to the proof of these things because we have already had a puri class. We spent one entire class on doing this stuff actually. So therefore, I'm just doing things directly. Okay. So you have to keep these things.
Yes,
For
sir.
example, so one theorem is a theorem that A union B minus A intersection B. Okay. A union B minus A intersection B is same as A minus B union B minus A. Okay. A union B minus A intersection B is same as A minus B union B minus A. Okay. This is really the two definitions for the symmetric difference actually. Sometimes you also call it. Okay. First, you can see it pictorially that, okay, I have this, what, A. So imagine this is my A, and this is my, I don't know, make it with the same color. This is my B. Okay. So what would be the union? The union is going to be this guy. So this is, so combine the both sets. All this stuff is going to be the union. This is my, so if this is A and this is B, then this entire set is A union B. And it says that from A union B, remove A intersection B. So if I remove A intersection B, what is going to remain? So what is going to remain is what? Is basically only these parts. Okay. So that's really is the symmetric difference, the one side. And see that whether you get the same thing on other side or not. Okay, so let's, I don't know, let's make A, and this is your B, A, and this is my B. So what does it says? From A, remove B. So let's first take A, the entire A, then remove the part of the A that is common with B. So which is the part of the A which is common with B? So it's really this intersection part. So I removed it. All right. So I removed it. And then what is the next thing? The next thing is really take, you know, B and remove A from it. So let's take, say, the entire B. So that's my entire B. And from this B, remove that part which is common with A. So which is the part that is common with A? So this is really the part that is common with A. Okay. So in other words, this part is your A minus B, and this part is your B minus A. And if you put them together, you're gonna get the precisely same, you know, this and this part actually. This part and this part. Okay. So that's really the pictorial proof of, you know, this. Okay. But here in this exercise, your task is not to prove this pictorially. It's good that first you should prove it pictorially. You should make sense of it through picture actually, and then try to prove, you know, this. Okay? Now, like at least in these basic cases, it is impossible to make the pictures actually. You're gonna see that after there will be a time when we can't make pictures actually. Okay, so it will be very difficult to make pictures. So then only this side will, this will kind of help us out. So in other words, what I have to do, I have this set and this set that are equal actually. And if you have to prove the equality, what you have to show that the left-hand side is a subset of right-hand side and the right-hand side is a subset of left-hand side. In other words, first I'm gonna prove that A union B minus, no, okay. So first I'm gonna show that A union B minus A intersection B, like this set, okay, is a subset of A minus B union B minus A. Okay, this is what that you have to do. So how I'm gonna show that this side is a subset of this? So I'm gonna pick an element, an arbitrary element from here and prove that the same element is also here. Okay. So let's pick an element from here. So let X is in A union B minus A intersection B. Now by definition, what does it mean? It means X belongs to A union B and X does not belongs to A intersection B. But what is the meaning of X belongs to A union B? It means that X is in A or X is in B. And what is the meaning of X does not belongs to the intersection? So we have seen it previously. This means that X does not belongs to A or X does not belongs to B. These are the two things. Now, this is an AND statement actually. And in AND statement, you have the four statements. Four possibility. X belongs to A or X belongs to B, and X belongs to A or X does not belongs to B. Now, there can be four kind of cases actually. Okay, so in other words, the one case could be that, okay, X belongs to A. In other words, in this AND statement, this part is true. In other words, X belongs to A and X does not belongs to A. And the other thing could be X belongs to A and X does not belongs to B. Okay, that's the second possibility. What could be the third possibility? That, okay, in this R statement, the second part is true. In other words, X belongs to B and from this, the first part is true. So X does not belongs to A. Okay. And the second thing could be that X belongs to B and X does not belong to B. So these are the four possibilities that, you know, logically you can have. But the question is, can this first possibility be true? I'm going to say no, because, you know, that's a contradiction actually, that X is in A and X is not in A. So that's a contradiction. This is not true. Can the last statement be true? That X is in B and X is not in B? You're going to say this is also a contradiction, so this can't be true. So the only possibility that you can have is this and what do you call this actually? Okay. In other words, okay. By the way, when I'm saying that there are four cases, so I'm saying that these are like R statement. Either this can happen or this can happen or this can happen or this can happen. Okay. So like these are the four are cases actually that, you know, it can happen that X is in A and X is not in A, or X is in A and X is not in B, and R, you know, all these are kind of choices actually. So the first and the last are not true. So the only thing that are true are this. Now, what does this second possibility mean actually? This really mean that X belongs to A but not B. Or what could be other possibility? X is in B and not A. But what does this mean? This means that X is in A union, or do you say B minus A actually? Okay. So what does this prove? We picked an element from this set and we shown that the same element is here. Okay. And so this means that this must be subset of J.
लास्ट स्टेप समझ में नहीं आया सर, थोड़ा उसमें
Last step समझ नहीं आया? देखिए, I'm saying that from these two statements, okay? So I'm saying that, okay, so imagine you have four statements, P, Q, R, S, logically, okay? And you have a statement P, R, Q, and R, R, S. I'm now asking from you, if you have a statement of this form, what are the possibility, under what condition this entire statement could be true? You're going to say this entire statement would eventually be true if the both parts are true. And
both
that's
of them are
P, R, Q is true and R, R, S, they both are true. True.
yes.
Now I'm saying, when can P and Q could be true? So one possibility is that P is true, from P, R, Q, P is true, and from this R is true. So if P is true, then P, R, Q is true. If R is true, then R, R, S is true, and hence this entire statement is true. So that's one possibility. What could be other possibility? That out of P, R, Q, P is true,
Q is
and
true.
out of R, R, S, S is true. So in this case, if the P is true, P, R, Q is true, and S is true, R, R, S is true, and hence this entire statement is true because the both parts of the end are true. Or if you can have the situation that P, R, Q is true because Q is true, and R, R, S is true because R is true, or you can have Q and what do you call S actually. So these are the four possibilities that you can have. And now think about it. Are we not, don't we have a same kind of a statements here actually? So two R and R statements. So there can be only four possibilities. That this entire statement can be true under the four circumstances. So in other words, X belongs to A is true and X does not belongs to A is true. X belongs to A is true and X does not belongs to B is true. Or X belongs to B is true and X does not belongs to A is true. Or X belongs to B is true and X does not belongs to B is true. But I'm saying that the first and the last are not possible because they are contradictions. So we are not interested in contradictions, just throw them away. So the only things that can be true is that either this statement is true or this statement is true. So I have just written it. Now by definition, if X is in A and X is not in B, then that's really the definition of X is, you know, in A but not in B. Or the second possibility that can be true is that X is in B and X is not in A. In other words, X is in B minus A. So if X is in A minus B or X is in B minus A, so the X must be in their union actually. ठीक है मेरा भाई? So this is what it is actually.
Yes, sir.
Okay, so this is what it is, and this really shows that that A union B is a subset of A union B minus A intersection B is a subset of A union B minus B union A. Okay, so this is what the one side of the proof is. Okay, so this looks like a complicated proof, but it's not actually. So you just have to think carefully about. You have to just carefully carry out the logic actually, and you can understand it. So for example, let's now move towards I don't know. Let's now move towards A. Okay, so not this. इसमें कोई सवाल है तो पूछें जरूर. So if you have any question, please do ask actually. ठीक है. Let's now prove the other inclusion actually.
Sir,
जी.
sir, can we not regroup the previous one as we make the possibilities?
But regrouping is same as making the possibilities. Regrouping is really making the possibilities actually. Okay, so this is precisely what is really true. Okay, so when you're gonna regroup, you are basically making the possibilities. So it's fine. So I have just written it more explicitly. Regroup kar le bhale, you're gonna get the same thing. ठीक है?
Okay, sir.
Okay, so A minus B union B minus A is a subset of A union B minus A intersection B. So that's what we have to prove. So let's prove it. So how to do it? So let's pick an element from A minus B. This must be straightforward. Minus B minus A actually. Okay. So what would be this? This means that X is in A minus B, or X is in B minus A actually. And this means that X is in A and X is in B. X is not in B. Okay. Or X is in B and X is not in A. ठीक है? Now, as you said, we can do the regroupings actually. Okay, so you can do your regroupings, but you have to do it very carefully that what law allows you to do the regroupings actually. So your regroupings should make sense. So now you can see actually, and the best way to do it is that if you have, for example, P, so think in the terms of the logic actually. Okay, so think in the terms of the logic. Always. So this is a kind of a statement which goes like this actually. P and Q, okay, this is and actually, so I'm always writing it as A. Okay, so P and Q are P, not R and S actually. That's kind of a statement. Okay. Now I'm asking the question, under what condition this entire statement can be true?
Any
So,
of the P and Q are R and S is true.
if any of the P and Q and R and S are true. So in other words, like you have two possibilities. P and Q is true, R and S is true. Okay, so if these both are true, then these are true actually. Okay, so how can I write it? So I can say P and Q is true, R and S are true. Now, can I convert this statement into an statement where I have an and inside it, in the middle.
Yes, sir, by negation.
By negation. Okay, that's one way to do it. But if I don't want to do negation, what should I do next? Can I say?
Conditional law.
Hmm?
Distributive property.
Yes, a kind of a distributive law of logic you can apply actually. Okay, you can apply, what do you call, distributive law of logic. Even you can apply distributive law of logic here directly. Okay, it's a good point actually. We have done these laws of logic, so why not to apply them? Okay,
Yes, sir.
let's apply them actually. Okay, so this is the time that we should use. So in other words, justify your thing. So P and Q are R and S. So I can say by distributive law, this means that P and Q are R is true. Okay, ऐसा ही होगा. And
Yes, sir.
P and Q are S is true. ठीक है?
Yes,
ऐसा ही होगा. ठीक है? So in other words, apply P and Q R with R first, and then this end. This is the end that is coming here actually. Then apply this entire bracket with R and S. So keep in view this. So if you have A, okay, so let's recall the distributive law. So if I have P and Q, R, say R, so you do that, okay, so you do the P and R, R, Q and R. Okay, so like this is what the law is. Okay? So precisely you're applying this law. So what you're gonna do? So now,
sir, I think there is a mistake.
अच्छा mistake है, क्या mistake है? चले,
Distributive law.
हाँ ठीक है, एक मिनट, एक काम करते हैं. Okay, so एक काम करते हैं. So always think, you're gonna feel that it's, this is getting difficult, and this is no. Always think through logic. Let's give this statement a name. This entire statement a name. What name should I give it? P and Q. Let's call it T. Not T, but maybe, I don't know. Let's call it B. Okay. Let's call this entire statement B. But let's don't confuse this B with this B actually. Okay. Otherwise we use some other symbol.
M कर देते.
M कर दें भाई. M कर दें. ठीक है. Let's call it M. So I have M, R, R and S, right? So by distributive law, this will become M, R, R and M, R, S actually.
M और S.
ठीक हो गया? अब M की जगह रख दें उसकी वापस वैल्यू. So you have P and Q, R, R and P and
Q,
Q, R,
or
S, and this is true. These are if and only if. So now you can even more explicitly write it. Now you can even more explicitly write it that P, R, R and P, okay, maybe I should use the symbol actually rather than, ठीक है, symbols ऐसी जगहों पर इस्तेमाल करते हैं where things get, really crazy. Huh? So P, R, R and P, नहीं, P, R, R और Q, R, R. ठीक है मेरे भाई?
Yes, sir.
And, okay, and Similarly, PRS and QRS actually. This is what that's going to happen. So in other words, this entire statement is equivalent to this. And now I'm saying that in this statement, replace P by, so take this to be P, okay? So take this to be P, this to be Q, this to be what? This to be R, and this to be S actually. Okay? And substitute these values in this expression and see what you get. So by this law, the above expression is true. P, that means X belongs to A, R, X does not belongs to A, right? Okay?
Yes, sir.
And X
गड़बड़ हो गया
क्या फिर गड़बड़ हो गई है?
Yes, sir.
क्या गड़बड़ हुई है?
Sir, here R is X belongs to B.
X belongs to B होना चाहिए सर.
अच्छा, X belongs to B होना चाहिए. चलो ठीक है जी, X belongs to B करना चाहिए. तो बताते जाओ ना यार. ठीक है, एक अकेला बंदा
मैंने किया.
अच्छा, आपने कर दिया. ठीक है, so in other words, just substitute the values and see what you get. So you're gonna see that you're gonna get a beautiful pattern. Huh? It looks like messy, but you can see that, you know, it's not that. So X belongs to B. And what is QRR? Q is what? So X does not belongs to B.
X doesn't belong to B.
R, X
belongs to B.
X belongs to B. Okay. And okay, so let me extend it. Okay, let me extend this page. ठीक है. So सबर वाला काम है थोड़ा सा. ठीक है. Okay. So what would be PRS? अच्छा, अब जो है I'm gonna put सबसे पहले तो let's put all of this in bracket and put an and actually. ठीक है. ये ऐसा.
Yes sir.
अब आप आ जाए दूसरे की तरफ. What is PRS? P क्या चीज है? X belongs to A.
X belongs to A.
R X belongs to B.
X belongs to B. पक्का?
Yes, sir.
S क्या चीज है?
And
नहीं. S is X does not belongs to A. ठीक है? X does not belongs to A actually. ठीक है? And Q is what? So
X does not belong to B.
X does not belongs to B, and X S is what? X does not belongs to X belongs to B. है? Q और S क्या चीज है?
X does not belongs to B.
X does not belongs to B. Okay, and
X
R.
does not belong to
X does not belongs to
A.
नहीं. फिर से देखो यार. S where is S? X does not belongs to S.
X does not belong to A.
ठीक है. X does not belongs to S actually. X does not belongs to A. ठीक है. If and only if. अच्छा, what is the meaning of this? This means that X belongs to A union B. And what is this?
Contradiction, sir.
That's a contradiction. और हम आपको पता होगा कि if you have a P and a contradiction, so if you have a P and a contradiction, you can simply get rid of the contradiction actually from the statement. So in other words, this is equivalent to P actually, and your contradiction, I just cancel it. ठीक है? ये हमने पढ़ा था लॉजिक में, याद है? शुरुआत में
Yes, sir.
symbols में we did
Yes,
this,
sir.
that if we have a contradiction just get rid of it. So get rid of it.
सर ये तो टोटोलॉजी है ना, कॉन्ट्रडिक्शन नहीं है।
नहीं, टोटोलॉजी नहीं है ना, कॉन्ट्रडिक्शन है ना। कॉन्ट्रडिक्शन क्या होता है? जो खुद भी ट्रू हो और what do you call
कॉन्ट्रडिक्शन में एंड होगा ना।
जो हो भी और ना भी हो।
Sir.
So x does not belongs to be, अच्छा it's a tautology, ठीक है, it's a tautology, ठीक है, ठीक है, ठीक। So it's a tautology। अच्छा, tautology के लिए ये होता है कि okay it does not add any information into the given statement, so you can get rid of it, still you can get rid of it, ठीक है। How about this? This is also a tautology, right? ये जो है,
Yes, sir.
this is also a tautology, so you can get rid of it. So what does remain then? Okay, what does remain then? The only thing that remains then is and x does not belongs to b and x does not belongs to a, means x does not belongs to the intersection.
Intersection.
And if you combine these two, what you're gonna get? इन दोनों को combine करें, that's precisely what is meaning of A union B minus A intersection B actually. Okay, and this completes the proof. Why? Because you wanted to show that A minus B is a subset of A union B minus A intersection B. So we picked an element from here and we showed it that this also belongs to here actually. समझ आ रही है बात? ठीक है?
सर
जी
सर जो हमने पहले वाला जो सबसेट वाला प्रूफ किया जिसमें assumptions लिए थे सर, x belongs to A, x does not belong to A, और x belongs to A and x does not belong, सर इसमें अगर हम सर यहीं पे डिस्ट्रीब्यूटिव लॉ अगर सर अप्लाई करें तो सर
फिर भी हो सकता है, फिर भी ये मैं डिस्ट्रीब्यूटिव लॉ ही अप्लाई कर रहा हूँ बेसिकली, ठीक है।
यस सर,
डिस्ट्रीब्यूटिव लॉ और जो कॉन्ट्रडिक्शंस है उनको मैं खत्म कर रहा हूँ, दैट्स व्हाट आई एम डूइंग एक्चुअली। सो आई एम डूइंग द सेम थिंग, ठीक है। सिर्फ यहाँ थोड़ा सा मैंने एक्सप्लिसिटली कर दिया बिकॉज़ यू नो आई जस्ट wanted to get into the detail, ठीक है। and you can see actually that you know this is where really the logical thinking that you are learning actually. This is not about sets actually that कि हमें ये identity से बड़ा को प्यार है जिसे हमें prove करना है, so we have to prove this identity, we are in love with it, okay, we are in love with this identity, but the key thing is we are learning how to think actually, how to argue correctly, okay, how to argue correctly. And what if I tell you that there is a one-liner proof of this entire identity? Only one line. In one line, you can prove this entire result. You don't need one page. ठीक है? But I want कि जब इस किस्म के proof आप करें, you should get into the details and do it. Okay. So what would be the one-liner proof of this identity? So let's think about it. It's really the one-liner proof actually. So the theorem says again, A union B minus A intersection B is equal to A minus B union B minus A. Can you think of a one-liner proof? Anyone? Keep in view this. So the proof comes from this identity that A minus B is the same as A intersection B complement. Can you see why this is true? Because if you take x from A minus B, by definition, this is same as x is in A and x is not in B. But this is what this set mean, right? यही तो definition है ना इसकी. A intersection B complement is what? Andy?
x belongs to A,
but x does not belongs to B. ठीक है? So A minus B is same as A intersection B complement. All right. So here's a one-liner proof. So what would be A union B minus A intersection B? So I'm gonna say this is same as A union B intersection A intersection B whole complement. But this is same as A union B intersection, apply De Morgan law on it. So you have the A complement union B complement. And then apply the law of De Morgan's. Okay, so I'm writing big actually. So if you apply the De Morgan law, what are you going to get? A union B intersection A complement, right? And union A union B intersection B complement. Okay. And then you do what? Then I can again apply, distributive law. So it's going to be A intersection A complement union B intersection A complement. This is what the first bracket means. And what will this guy will become? So A intersection B complement union B intersection B complement. Now what would be A intersection A complement? What is A intersection? If you intersect a set with itself, what are you going to get?
Null set, sir.
You're going to get
Null
null
set.
set. You're going to get null set. You're going to get phi union B intersection A complement and union A intersection B complement union empty set. Okay. So if you add union into it, what you're gonna get? Nothing. But what is B intersection A complement? This is B minus A. Union A intersection B complement. This is A minus B, and this proves the theorem. Okay, this proves the theorem. So that's another way to do it. But in this, I have assumed a lot of previous knowledge actually, that I know that distributive laws are true for sets, and I know that so there are several things that I have assumed about sets. But in my previous proof, I assumed nothing except the laws of logic. Okay, so the things can be done in the several ways, the proofs. Okay, so this is how you have to prove, what do you call, different things actually. Okay, is there any question in this?
Sir,
Gigi?
we say that the null set is a subset of every set. How can we prove it?
Okay, so null set is a subset of every set. All right, that's a very good question. A typical question that we quite often encounter actually. Okay, so what is the definition of being subset? So A is a subset of B if and only if for all x belongs to A implies x belongs to B, right?
Yes,
but
sir.
This is equivalent to its contrapositive. You agree with this? Would be equivalent to its contrapositive, that if x is not in B, this implies that x is not in A. Okay.
Yes, sir.
Or I can say that, okay, for all x, if x belongs to B complement, this implies that x belongs to A complement. All right. So keep in view this. Now I want to prove that, okay, so take, A to be any set and phi the subset of it. So in order to prove that phi is the subset of A, I need to prove this. Okay. I need to prove this, that any x, so I need to prove that for all x, if x belongs to empty set, this implies that x belongs to A. Okay. But like, this is troublemaking. What do you mean by x belongs to empty set? What do you mean by x belongs to empty set? There is nothing inside of it. So how can I say that x belongs to? But if you think about the contrapositive of it, it makes complete sense. So if for all x, if x does not belongs to A, this implies that x does not belongs to, what do you call, phi actually. Okay. Is this a statement true? This is true indeed. So in other words, if you pick an element that is not an A, that element would not be an empty set. In fact, this is true in general actually, that whether x is an A or not doesn't matter. X would not be an empty set actually for all situations, no matter what happens. So this implication is true. Do you agree that this implication is true? That any x that is not an A is also not going to be an empty set.
Yes, sir.
So if this implication is true, then this is true. And if this is true, then this is true.
Excuse me, sir.
There you go. You have proved that phi is a subset of A. J.
सर मैं लीव कर सकता हूँ?
Sure.
थैंक यू सर.
ठीक है जी.
सर
जी.
सर जो लास्ट स्टेप आपने किए ये थोड़ा एक्सप्लेन करेंगे.
I have just done the contrapositive of above statement. Contrapositive समझ आ रही?
Yes sir.
चले यूं कहें कि this is same as for all x. Let me use. If x belongs to A complement, implies that x belongs to, what would be the complement of phi? The universal set. ठीक है?
Yes sir.
अब मुझे बताएं, is this statement true that कि हर वो x which is in A complement, it is also going to be in the universal set? Is this a statement true?
Yes sir.
But yeah, if this statement is true, this is equivalent to this statement. It's the same thing actually. And if this is true, then this is also true. And if this is true, then this is also true. Okay. So if you want to directly understand this statement like this one, so what does this statement is telling? Any x that is not an A is not going to be an empty set. So that's in fact true actually. So you take any element that is not an A, would that element can be in empty set? Can that element be in empty set? So you're going to say no. So this implication is true. So if this implication is true, then this is true. And if this is true, then the phi is subset of A. So the phi subset of A is a very trivial kind of an object, but it's good that we should think logically about it actually, that okay, why this is true. Okay, why this is true. So the logic is helping you to make sense of it. Otherwise, you know, you're gonna have the speculations actually. ठीक है, you know, वो जो टीचर साहब को बचपन में बताते थे ना कि भाई ये क्लास में स्टूडेंट है और फिर क्लास में हम चले जाएं, क्लास से चले जाएं तो एम्प्टी सेट हो जाता है, और जो है वो एम्प्टी सेट हर एक का सबसेट है, और एम्प्टी सेट में तो कुछ है ही नहीं, तो वो कैसे सबसेट हो सकता है? Anyway. So that's really the logic. Is this logical proof making sense to you? ये समझ आ रही है बात? भाई वो जिसने पूछा था, किसने पूछा था? Who knows?
Yes, Ejaz.
चलो भाई एजाज भाई, तो आपको समझ आ गई बात थोड़ी सी, ठीक है?
Somehow, sir.
Somehow. चलो इस पर थोड़ा गौर करेंगे तो देखें, if you trust this that a statement is true if and only if an implication is true, if and only if its contrapositive is true, so by this argument is valid actually, because इस
Yes, sir.
statement का contrapositive ये है, so, and this is true. So if the contrapositive is true, then the statement itself is true actually, and hence the phi subset of A definition is satisfied actually. ठीक है मेरे भाई?
Yes, sir.
जी जी.
सर ये मैथमेटिक्स में भी हम ट्रस्ट कर सकते हैं चीजों पे?
Why not? You have to trust it. You have to trust at least logic. You know, देखो ना. So logic. So how did we started logic actually? We started logic from a very basic fact. You remember? we started logic from basically so-called law of no contradiction actually. Law of no contradiction. What do you mean by that? That a statement and its negation can't be true at the same time. So if this is true, this must be false. If this is false, this must be true. Okay? So this is law of no contradiction. Okay. Did I prove the law of no contradiction? No, I taken that as a fact actually, a brute fact. That, okay, let's assume that law of no contradiction is true. बाकी जितने भी laws हैं वो सब के सब इसके नतीजे हैं. So everything that is else is really the consequence of law of no contradiction. ठीक है? And do we have a proof for law of contradiction? Is there a proof of it? The answer is no. There is no proof for law of contradiction. So we trust it. Why we trust it? Because it is intuitive. It seems logical actually. It seems rational. A thing cannot be and can be at the same time actually. ठीक है? And if we say that law of no contradiction is if we don't trust law of no contradiction, then we will live in a very strange world. So imagine I give you A grade, okay, and you say that you haven't given me A grade actually, because giving A grade in a course is the same as not giving A grade actually, because both things can be true. Okay.
Yes, sir. Yes, sir.
When you are saying that there is light, then there is no darkness actually.
Yes, sir. Yes.
We have seen it. If there is no darkness, then there must be light. And if there is no light, then there must be darkness actually. Okay? So this law of no contradiction is naturally observed actually. We can see that this is true. But this is a trust actually. Okay? This is really a trust on the law of no contradiction. So if you assume this law of no contradiction, the rest of the things can be logically carried out actually. Okay. And there was a guy, whose name was Hume actually. He even doubted this actually. He even doubted this, why all these laws are true. Okay, so if he said, how do you know that if you knock a glass actually, it is going to make a noise like this? You trust this because you have observed over and over that when you knock a glass, it is going to make a noise. So the next time if you knock a glass, is it going to make a noise? Hume says, don't trust it, may or may not be. So he was a crazy guy who even really mistrusted or distrusted into the very foundations of the logic as well actually. Okay? So everything starts from some kind of assumptions beta. Okay? So your assumption should be rational, that's it. Okay? But the rest of the things should be carried out through the logic actually. And this is an important thing. Okay? Acha. Now I would like to give some definitions to you so that you can do this 5.2 exercise. I'm not going to do any new things today. Just going to talk about a little bit about sets actually. Okay. So that you can do this 5.1 exercise in a more convenient manner actually. By the way, how many of you guys know what is a cross set? This A cross B. Okay, what is A cross B? If A cross B is
Cartesian product. Cartesian product. A cross.
it's a collection of the ordered pairs A, B,
Yes, sir.
where A is in A and B is in B actually. Right? That's really in the set builder form of a Cartesian product actually. All right, if A is in A and A is in B, then is in, the ordered pair A is in A cross B. And this seems like a very uninteresting thing actually, that, okay, what is really the Cartesian product? But I can tell you that, when you're gonna, for example, do the course on topology, you can actually, see that this Cartesian product is very, very interesting and exciting object actually. For example, let me give you a glimpse actually. Let me give you a simple glimpse. Okay, so aside from set theory, so it's just fun fact. So if I say that I have, I don't know, interval 1 cross 2 cross product 1 cross 3, or maybe let's not do this. Let's just do this. Say R cross R. Let's try to make sense of R cross R. That what is R cross R actually? By the way, A cross B can also be written in this manner, that pick an element from A and compute its cross product with entire B. Pick an element from A and compute its entire product from B. And then do the union of all such sets actually. In other words, with every point in A, okay, with every point in A, associate a copy of B actually of it. In other words, if this is my A and this is my B, that's my A and that's my B, then what does A cross B say is that to every point in A, attach a copy of B. Okay, to every point of A, attach a copy of B actually. So it's like I'm attaching a copy of B at all points actually. So you have to do this on all points. So I have left many points inside, okay, but assume that, so to all points I have attached the copy of B. So what would be R cross R? So think about it. So I have R and I'm taking its cross product with R. What does it mean? It means to every part, say for example, this is 0, okay? To every point in R, attach an R actually. Maybe a vertical R, okay? So attach a R. To every point of R, attach a R, okay? So that's how you have to attach. To every point of, R, attach an R. So if you're gonna attach it, what you're gonna get? Imagine that I'm leaving no gaps actually. What you're gonna get? You're gonna get a plane actually. Do you agree with me that you're gonna get a plane? तो समझ आ रही है बात, नहीं आ रही?
No, sir.
नहीं आ रही समझ. चलो इसको यूं समझते हैं. So let's try to make sense of it first for the case of this actually. इसको समझने से पहले let's try to visualize this simple case actually, that okay, I have this one set, say A, and I have this another set which is vertical, this. Now treat this green line as a stick actually, and red line as also a stick. Now I'm saying that to every point on red line, attach a green line actually. Attach a green line to every point. So what you're gonna get? Can you tell me what you're gonna get? You're gonna get basically a rectangle.
Yes, sir.
A green rectangle. Okay, a filled green rectangle, because to every point you have, okay, you have this actually. Are you getting the point? Okay.
Yes, sir.
How about if I now take a green line, okay, and say, okay, let's take a green line and and take a circle actually. Okay, take a circle, and I'm saying that take the cross product. Okay, so create an object that is going to be so I can so for example here I can say that this green rectangle is really the cross product of a red line crossed with the green line actually. ठीक है, इन दोनों की क्रॉस प्रोडक्ट है this green rectangle. So I want to ask from you what would be the meaning of the cross product of say a line with a circle. Can you guess what would be the meaning of it? So what does it is going to mean is that take your circle and to the circle attach at every point a green line at every point, or maybe to every point a green line attach a copy of a circle. So that's another thing actually. So for example, to this point attach a copy of a circle, to the next point attach a copy of a circle, to next point attach a copy of a circle. So to every point you are attaching a copy of a circle actually. Okay, the same circle with the same size. So what do you think what you're gonna get? Slender
Cylinder
actually.
type.
Very good. So it's like चूड़ियां देखी आपने कभी? Have you seen the bangles actually?
Yes, sir.
So what I'm saying is that okay, take a stick actually and put the and to every point like put a bangle on each other. So what you're gonna get? You're gonna get a cylinder actually. Okay, you're gonna get a cylinder. So when you take the cross product of a line with a circle, you get a cylinder. So cylinder is a cross product actually. And you can do the same other way around. That okay, take circle and attach a line with each point of the circle, a vertical line. So again, you're gonna get a cylinder. समझ आ रही है बात? Now I ask from you that if I say that okay, you have a circle and you want to take the cross product of circle with another circle. So can you imagine a picture in your head that what picture you're gonna get? And you have to keep one thing in head that ऐसे समझ लें कि one circle is laid down, it's in it's laid down horizontally, और दूसरा circle जो है ना kind of vertical है, ठीक है? So what would be the cross product of circle actually? So in other words, to each point attach a circle. To each point attach a circle. To each point attach a circle. So do you think, can you imagine that what you are getting? What are you going to get? क्या बनेगा?
Sir, round type cylinder, sir.
Round type cylinder?
एक शेप बनेगा जिसके एक साइड पे सर्कल होगा, बाकी ऊपर साइड में सिलेंडर बनेगा.
So it would be a tube actually. Tube को imagine करें.
Tube, sir.
ठीक है? Donut. So if it would be a kind of a tube actually. So this is what the shape that you're gonna get, huh? So this is what the shape you're gonna get actually. ठीक है? समझ आ रही है बात? So I can give you more fun fact. I can give you that. Imagine you have a circle and attach to every point in circle, for example, this object. तो क्या बनेगा? So to every point of the circle, attach this. To every point of the circle, attach ठीक है, हर पॉइंट ऑफ सर्किल के साथ अटैच करें तो क्या बनेगा? तो सुराही टाइप बन जाएगी, सुराही. सो यू गोना गेट समथिंग लाइक दिस एक्चुअली, अ वेसल.
Yes, sir.
Can you imagine? You're gonna get a kind of a vessel actually.
ये तो सिर्फ दो पॉइंट में अटैच किया तो वेसल बनेगा ना सर?
नहीं, दो नहीं ना, यदि आप ऐसे समझ लें कि पूरे सर्किल के हर पॉइंट पे अटैच करते जा रहे हैं. सो टेक अ सर्किल एंड और हर पॉइंट पे अटैच करते जा रहे हैं. अब वो उसे बनाना मुश्किल है, दैट्स रियली द ट्रबल एक्चुअली. ठीक है,
हाँ तो वो 3 डायमेंशन बनता है.
हाँ 3 डायमेंशन बनता है. ठीक है, इसे यहाँ बनाना मुश्किल है, बट यू कैन रियली see it actually that kg, you know, you're gonna get a a Surahi type shape actually. So all these are Cartesian products. All of these are really the Cartesian products actually. Okay. So you can take all kind of objects and create the new objects out of the Cartesian product. So this boring looking like thing, we're gonna see also later that it can represent a lot of things actually. ठीक है जी, चलें, it's already 12, so let's do this stuff in our next class. But as I said, that try to do the mathematical induction and then try to prove the theorems from the exercise of 4.2 actually as much as you can. Okay, so exercise.
सर काइंडली एक्स्ट्रा क्लास के लिए वो कर दे सर.
तो वो आप आपस में सेट कर लेना टाइम. सो सेट अप अ टाइम एंड लेट मी नो. ठीक है,
ओके सर, ओके.
ठीक है, क्योंकि आप लोग मुझे आपकी क्लासेस कब है मुझे तो नहीं पता. आई डोंट नो व्हेन यू हैव द क्लासेस एक्चुअली, एट व्हाट टाइम्स. सो जस्ट
फर्स्ट टाइम होते हैं सर.
फर्स्ट टाइम में होते हैं.
हो रहे हैं तो सर. हाँ सर.
So how about tomorrow, say 3 to 6, or maybe 3 to 5, whatever. Tomorrow.
जी सर, कल हो तो सही है.
ठीक है, तो ये बाकी लोगों से मशवरा करें और फिर मुझे बताएं. Are you guys happy with 3 to 5 tomorrow for problem solving session? चलें डिस्कस करके मुझे बताएं फिर. So tell me through the way. चलो जी, wish you good luck. So see you tomorrow.
ओके सर.
Allah Hafiz.